In this video, we're going to go over the product to sum formulas. And what that is, it's these formulas for what happens if you have sine times sine, or sine times cosine, or cosine times cosine. And where these formulas come from are from the sum identities. So we have the formula cosine of alpha plus beta equals cosine alpha cosine beta minus sine alpha sine beta. That's the cosine sum formula. And we also have sine of alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. So I'm assuming that you're already familiar with these. And recall that cosine is an even function. So cosine of negative theta equals cosine of theta. And sine is an odd function. So sine of negative theta equals negative sine of theta. So once you have these two, let's call this 1 and 2, you can find formulas for cosine of alpha minus beta and sine of alpha minus beta. So how would we find cosine of alpha minus beta from the first formula? Well, the idea is to change beta to negative beta. So you replace everywhere you see a beta, you change it to negative beta, right? So beta here will be negative beta here, beta here will be negative beta here, and then you use the even and odd properties of cosine and sine to change that. So this is going to be, okay, let's write it all out. So from the first one, when you replace beta by negative beta, and you use the first identity, you get cosine alpha cosine of negative beta minus sine alpha sine negative beta. But we know that cosine of negative beta is cosine beta. So you're going to get cosine alpha cosine beta. And then you know that sine of negative beta, this is negative sine beta, using the even property, using the odd property of sine, right? So you're going to get negative sine beta, and then you have this negative here, and that's going to cancel with the negative here. So you're going to get plus sine alpha sine beta. So now we get this identity. Okay. So let's put this one in a box. Let's put this one in a box. Let's put this one in a box. Let's put these two in boxes. Okay. And similarly, you can get a formula for sine of alpha minus beta using equation 2, because if, again, you just do the same thing, you replace beta by negative beta. So when you do that, you're going to get sine of alpha cosine of negative beta plus cosine alpha sine of negative beta. And then again, you use these two facts about cosine and sine being even and odd. So this is going to be sine alpha cosine beta, and then minus cosine alpha sine beta. Okay. So you get these four identities. These are the, like something, I forgot what they're called. Okay, it's like the cosine and sine sum and difference properties, 1, 2, 3, and 4. Okay, well, using these, we can just do some simple algebra to get what are called the product to sum formulas. So if you take equation 1 and add equation 4, okay, what does that mean? Well, if you look at equation 1, we know that that is equal to that. And from equation, am I adding the same? Hold on. Oh, sorry, equations 1 and 3. Okay. And then from equation 3, we know that this is equal to that, right? So that means that if I add this and this, I should get the same as that plus that. Because they're the same thing, right? They're equal. And what's going to happen is I have a cosine alpha, cosine beta here, and I also have a cosine alpha, cosine beta here, and then I have a negative sine alpha, sine beta here, and a sine alpha, sine beta there. So when I add the two equations, the sine alpha, sine beta terms are going to cancel. And then I'm going to get 2 cosine alpha, cosine beta, and then I can divide both sides by 2. So when I do that, I get cosine alpha, cosine beta equals a half of cosine alpha plus beta plus cosine of alpha minus beta. Let's put that in a box in a different color. So that's a formula for the product, cosine alpha, cosine beta. And we can also get a formula for sine alpha, sine beta by doing, okay, what are we going to do? Let's see, where do we see sine alpha, sine beta? We see sine alpha, sine beta here, and we see sine alpha, sine beta there. So it looks like we can do equation 3 minus equation 1. So if you do equation 3 minus equation 1, what's going to happen is cosine alpha, cosine beta will cancel, and then you can divide by 2 to get the sine alpha, sine beta by itself. And when you do that, you get sine alpha, sine beta equals 1/2 times cosine alpha minus beta minus cosine alpha plus beta. Did I say that right? 1/2 times cosine of alpha minus beta minus cosine of alpha plus beta. So let's put that in a box. And then finally, we can get an expression for sine alpha, cosine beta. How are we going to get sine alpha, cosine beta? Where do we see those? We see those. There's one here. And there's one there. Okay, so we're going to add equations 2 and 4 and then divide by 2. And then the cosine alpha, sine betas will cancel. So adding equations 2 and 4 and then dividing both sides by 2 gives us sine alpha, cosine beta equals sine of alpha plus beta plus sine of alpha minus beta all over 2. Or, 1/2 times, okay, you know what I mean. 1/2 times the quantity sine alpha plus beta plus sine alpha minus beta. For this one, I just wrote the whole thing divided by 2. So these formulas that I boxed in red, these are called the product to sum formulas. But they're really just what you get from taking the other formulas and just doing some simple algebra, right? Yep. And, oh, by the way, maybe we should just, if you look in some books, they'll have a formula for cosine alpha, sine beta, but that's really from the sine alpha, cosine beta. I mean, sine alpha, cosine beta is the same as cosine beta, sine alpha, right? Because you're just taking two real numbers. When you multiply them, doesn't matter which order you multiply them. And then you just replace the beta by alpha and the alpha by beta. So when you do that in the formula, you're going to get sine beta plus alpha plus sine beta minus alpha over 2. And then beta plus alpha is equal to alpha plus beta. So you're going to get sine of alpha plus beta. And then this beta minus alpha, you can just change that to negative parentheses alpha minus beta. And then use the fact that sine is an odd function to pull the minus sign out. So you're going to get minus sine of alpha minus beta over 2. So sometimes people will, if you look in a book or something, they might like box this one as a fourth formula, but it's really the same as the previous one. So those are the product to sum formulas. How useful are they? That's a good question. They do show up sometimes, but the main application I know of is, so for instance, if you wanted to integrate sine of 7 theta times sine of 6 theta or something, then you would use this product to sum formula. And when would you ever need to do that? Well, actually, it turns out that this product to sum formula, we will see in another video that when you use it, you get some somewhat surprising facts about sine and cosine and the integrals. And these play an important role in something called Fourier series.